picking up good vibrations.
So let us start by providing some motivation or deriving the formula to go from the cosine sine representation into the cosine representation where the cosines have a given phase phi of k. Now, this simply relies on a very simple trigonometry identity, which is written here at the top. Basically says that you can write the weighted sum of a cosine and a sine as just one cosine, but with a phase. Now, the amplitude and the phase of the resulting cosine can be obtained by these formulas here, and nothing more than if you first write the complex number a minus jb, if you take the absolute value, the square root of a squared plus b squared, you get the amplitude d of the resulting cosine. And if you take the angle of this complex number a minus jb, you get the phase of the resulting cosine phi. Now, of course, in the formula of the cosine sine representation, so basically this formula, a naught plus the summation from k equals 1 till given capital N of bk cosine 2 pi over capital T kt plus ck sine 2 pi over capital T kt. I can now group this capital N might also be infinity if we're talking about the Fourier series. I can, of course, group for each k, I can group this cosine and this sine. And I'll get, then if I do so, I'll get this conclusion that I can write this cosine sine representation as simply a representation that only has cosines and the formulas for these dk's and phi k's are nothing more than these ones that we obtain from the ones on the right hand side. If we have the cosine sine representation, the a naught, bk's, and ck's, we can get the a naught, which is the same, the dk's and phi k's. If we have the dk's and phi k's, we can still recover the bk's and ck's because we can always plot this complex number and recover its real and imaginary parts. This justifies the formula that we see for this conversion between the cosine and sine representation and the cosine representation.